the new session of Operation Research. In past lecture, we understood what is a network diagram, what is a network analysis, how we draw our activity or how we interpreted our activity on the network diagram, and what are the main key terminology to draw a network diagram, what is arrow, what is node, and extra, and what is the basic guideline to draw a network diagram. These all are basic parameters we already understood in last lecture. So today we will learn a project evolution techniques, that is a CPM and a PERT. So this full form of CPM, that is critical path method, and a PERT, that is a project evolution and review technique. This both technique we are used to solve and to optimize or to calculate our overall project time, right? So what is the basic funda behind the CPM? What is the basic funda? What is the history behind the PERT? We will learn in today's session. And let's take one example over there. So what is a critical path? Means suppose you have to take a project of your competitive exam as your preparation part of your life. So what you decide? You decide to start your preparation by simple making a timetable. So what you consideration in timetable? Suppose you have to do a job, and with job you have to do your preparation of your competitive exam. So you have to consider all your time as 6 to 7 or 5 to 6. I wake up and first I read a newspaper, then after I do some basic revision of which I studied in last night, and from office time I do such kind of the activity or such kind of the preparation. All the parts you have to manage. But during making or during a timetable preparation, you have to consider some critical conditions, as that suppose you have given 2 hours time of preparation in office time. So what happened? Some critical condition, that is you have a back-to-back lots of meetings, so you can't give the time to them. So you have to give a very less timing of the preparation in office hours, because that is a critical condition. You never know your office during the office times you get a perfect works, right? So this is the basic funda, and you have to calculate that project, right? Another example we have take as a building construction. So what builder do? Builder will propose that projected time or completion of projected time, and that completion of projected time is submitted in RERA, that is the regulatory authority of real estate, Gujarat. So what happened? They give a proposed completion time to the RERA, and RERA approves. So that proposed completion of time, builder decide based on their past experience, and they have also considered all the parameters, all the critical conditions, as he or she calculated as he completed the project within 2 years, but since they so as a completion time for 3 and 4 years. Why? Because they have get the spare times to complete that project. Means they have to give a maximum time for completion of projects, right? So this is the basic funda of project calculation, project time calculation, how we calculate the project and which we have to consider. So for based on that project time calculation, we will learn in today's session, that is CPM method and PERT method. So what is a CPM? What is the history behind the CPM? So CPM, that is critical path method. If first it is a project modeling techniques which is developed by a US Navy, and which is invented by a first scientist, that is DuPont, and it used in a missile defense construction in US Navy project, and first time CPM was used for making a major skyscraper development in Twin Tower City in World Trade Center in New York. Right? So this is the history of the CPM, at where CPM first used and who was invented. Right? So what is a critical path method? The critical path method, or CPM, is an important part or important technique for project planning, and it's a project planning tool to monitor the progress of the project and to ensure that the project is on schedule. Next, the critical path for the project is the longest sequence of the activity on the network diagram, and it's categorized by the zero slack for all activities on the sequence. Means we have a different activities, so we have put the different activities in a network diagram, and for different activities we have defined some time interval, or for some time we have put the time on that such activity, so we can get a critical path from that activity and time duration. Next is this means that a smallest delay in any activity on critical path will cause a delay in overall timeline of the project. So this is the important part. If a minor delay in any other activity or in a small activity of a critical path, it will affect overall project time, right? It will affect overall completion time of the project. Let's take a simple example. During corona pandemic, government imposed a lockdown. So because of lockdown, what happened? Many construction sites were closed, and they have a builder stopped their work of a site, and for safer side, many laborers went their native place in this lockdown period. So what happened? During that lockdown period of 1, 2 months, 3 months, the construction site was closed, and there is no work was there on site. So what happened? That is the delay in 3 months. That builders will give, that builders already submitted their completion time in a RERA, as I have completed my project in December 2020 and in December 2021. But what happened due to that corona, or by imposing that lockdown, some a time interval was mismatched, so they have give application to that RERA, please extend our project time, completion time, and that delay, that minor delay during the lockdown, that will affect overall delay in a project completion time, right? So this is the basic simple example of smallest delay, right? If needed, the project manager can divert a resource from other activities and that are not on the critical path, on activities on a critical path, to ensure the project is not delayed. Means project managers give an assurance that and keep a full attention on that a project will not be delayed, right? So next, what is the major 6 steps we have to follow for CPM and path? So first we define the project and identify each activity. We have to define the project and identify each activity for draw a network diagram. Develop the relationships among each activity and decide which activity must be precede and which must follow. Means we have to define and develop a relationship. Means in data they have give a predecessor activity as XYZ activity is a predecessor activity, or they sometimes give as successor activity of this activity. So you have to develop that relationship on a network diagram as a predecessor activity and successor activity, right? Third one is to draw a network diagram by connecting all the activities, right? Fourth one is assign a time or a cost estimate of each activity in a network diagram. Fifth steps, compute the longest time path through the network, that is called a critical path. As we already discussed that we give our project time as a maximum project time, as a longest path or longest time. That longest time or that longest duration is known as a critical path, right? Use the network to help plan, schedule, monitor, and control the project, right? So these basic 6 steps we have to consider while calculation of a path and CPM. What is the guidelines for a network diagram? Basic guidelines for to draw a network diagram. So no single activity can be represented more than once in a network. The length of the arrow has no significance. Means we have a single activity. We have only introduced a single activity at one time. We can't do it a repeated time. Means suppose we have give one activity as node 1. So node 1 is can't be repeated throughout all the project, right? And we have draw a arrow for indication of activities. That length of arrow can be not any significance and then not be in a standard format. Then this type of length we have, right? Next, the event of number 1 is a start event, and event of last number, highest number, that is called an ending event. Means you have to start your event from node 1 and you have a largest or latest node event as a 7 number. So your 7 number node will be considered as an end event number. Clear? So before an activity can be undertaken, all the activities preceding it must be completed, and that activity must be followed in logical sequence between them. Means we have to perfectly draw, we have to perfectly give a perfect relationship of that all activities as a preceding activity and as a successor activities in a logical sequence. In assignment numbers to the event, there should not be any duplication of event number as already discussed to avoid danceling and looping, right? A dummy activity must be used only if it is necessary to reduce the complexity of network. When we are using dummy activity, we have used a dummy activity to reduce the complexity of network. But when required, at that time we have to use. Suppose we have drawn a network diagram, we have not implying any logical sequencing and any logical steps. We have to draw a network diagram and we think that we can't complete the project, or we have entered a dummy. But if we apply that network diagram in logical sequence and logics, with the logics, we can't introduce any dummy activity. So keep in mind, when we introduce a dummy activity, when a network diagram has a complexity and there is no way to draw that activity or no way to introduce that activity, at that time we have to use a dummy activity, and which will be denoted as a dotted line. Clear? A network should have only one start, only one end event. Clear? So what are the basic key terminology of a CPM part? We learned as a path, that is an unbroken chain of activity of arrows and connecting the initial event some other event, that is called a path. That is the number of activities lies on one direction, that is called as path. A network, that is a graphical representation of logically and sequentially connected arrows, nodes, which representing activities on events of the project, and that graph will shows the relationship of the activities and cost and time duration of that activities. That is called a network, which start from activity to the end of activity. Whole graphical represent is known as a network, and those activities which contribute directly to the overall duration to the project, and critical activities, and that critical activities from the chain running through a network, running through a particular path, that is known as a critical path. Clear? Critical event, the slack of an event, the difference between the latest and earliest event times. The event times with the zero slack are called critical events. We already apply this terminology, how we calculate critical path, how we identify the critical path, all the things we will learn in example. Critical activities means that activities lie on critical path. We know and the critical activities means the difference between a latest start time and earliest start time of the activity indicate the amount of time which activity can be delayed without affecting the project duration, and the difference is called the total float activity, and which zero total float are called the critical activities, right? Next is earliest time, the calendar time when event can occur when all the previous events completed at the earliest possible time. Latest time, this denoted as TL, which is the latest time the event can occur without delaying the project or subsequent events or activities. Slide, that is the difference between the latest time and earliest time of the event. Total float we have to calculate here in critical path method. We have to calculate different types of float, that is a total float, free float, independent float, interfering float. So how we calculate that float? The total float will be latest finish time minus earliest finish time, or latest start time minus earliest start time. We take the difference, we find we can get a total float. What is free float? So free float will be time by which the completion of an activity can be delayed beyond the earliest finish time without affecting earliest start time of the project or activity. So what is the free float? Free float, this is earliest start time succeeding minus earliest finish time of a present activity, right? Interfering float. So interfering float, that is a part of the total float that cause a reduction in total float of the successful activities. That interfering float, that is the equation is latest finish time of present minus earliest start time of your succeeding activities. Independent float, amount of total float that can be used without affecting either of succeeding or a preceding activities. That is independent float, that is earliest start time of succeeding minus latest finish time of preceding minus a duration of present activities which already given in a data, right? So these all are a basic key terminology of a critical path method, and the total float, free float, interfering float and independent float, that are the parameters we have to find from the critical path method techniques. Clear? So this is the end of today's session. In next lecture we will learn an example of CPM part, CPM. So in that lecture we have to identify how we find out the CPM, how we introduce that activities on a network diagram, how we find out the various type of floats. Clear? So thanks for watching.